How do we solve systems of equations? Well, first off, let's remember what a system of equations is, and we'll call them an SOE from here on. But basically, it's where we consider two equations or more than two equations at the same time. Now, these equations we're looking at are all going to be linear, which means that when we graph one equation, it creates a line. And so when we look at two equations, you should be looking at two lines. And you've got pretty much three different ways that would happen. The two equations might intersect in one spot. So where they intersect is your solution. So this point that touches both lines at the same time, and you can see it would be right here. That is your solution, and it gives you an x value and a y value, or what we would call a point on the Cartesian plane or an ordered pair, and it says, hey, it represents this point right here. However, if the lines don't touch, don't panic, it just means there's no solution to that SOE. But if you graph two lines and it came up with this odd situation of the line was like right on top of each other, well, if you notice, it would have like an infinite set of points that would be the touching both lines, and so you'd have infinite solutions. And that's what we're being asked to do is please go solve this SOE, and there's different methods that we can use to solve it. The first method is what we would call the graphing method, and that's where you literally have your own graph and you go and graph the equations. So here's the first line that's graphed, y equals negative 4x plus 1, and then we go graph the second equation, and where they touch, you'll see it would be right here. That becomes your solution. So this point of 1, negative 3 is your solution. Now, I've got this written right here to show you. You can make a little note of what your x is and what your y is, but you should be writing it as if it was an ordered pair. So let me write that a little bit neater. This is the solution to this system of equations because we're saying what's the solution to equation number 1 and equation number 2. And since this point right here is touching both of the lines, it's the solution to both of the equations. That's your solution to this SOE. So here's our second time using the graphing method, and it'll be the last that I use today. We graph the first line in red, graph the second line in blue. Where they touch, negative 2, positive 3. And so this is our solution, negative 2, 3. Now, why don't we just stick with graphing method to solve all of these SOEs? It's not always going to be in a nice even spot where the numbers are nice and precise and give you an integer. It might have a very odd fraction like negative 1 1/3, or it could have an irrational decimal in there. This is 8th grade math though, and so we're going to keep it rather calm and tame for you, but we are going to give you some other methods of how to solve these. And the one that we've looked at in the past has been the elimination method. And this is what you should be familiar with. Okay, I've been given two equations, so let's just add them together. And magically, every single time you got something like this. 7x plus 1x is 8x. But the positive 2y and negative 2y right here, when you add those two together, it gets you 0. And negative 8 equals negative 8 is negative 16. And I taught you, hey, go ahead and solve for x. And you go, cool, x equals negative 2. And everybody liked that. Well, first off, a small disclaimer. You will not always be able to add these equations together and get a nice, perfect solution here for x. Sometimes you add them together and you'll still have two variables. But for these examples today, it'll work every time. The thing I want to focus on today is we got one variable. Let's go get the second variable. How do we get this y? Well, you have a decision to make. You can go and solve for y by taking one of these equations. It does not matter which one of these original equations, and plug in your x value. So do you see this x here all by itself? Let's just go and plug x in there. Now, because I know what this x is, because remember, the x originally was sitting here, but we didn't know what it is. We didn't know what x was. Now we do. That lets us be able to say, you know what, this x sitting right here, let me just go plug in that as a negative 2. So negative 2 minus 2y equals negative 8 is what we're left with. Hey, guess what? You can now go solve for y. This is not new. This is the same thing it used to be. It used to be I'd give you one equation and go say, hey, go solve for this variable. This becomes 0. We'll pull down negative 2y, and this is negative 6. Well, that's kind of cool. Divide both sides by negative 2, and I see that y equals positive 3. Now, again, this is just here kind of as a note-taking situation here, but I really want you to be able to write your solution as an ordered pair, because if I went and graphed these two lines, it might look like something like this, but where they would touch would be negative 2, positive 3. Okay, but we don't need to graph it anymore. We've got this elimination method here. Now, I understand your concern is, well, how do I know if it's right? Well, if you take both of your equations and you plug in your x and y values, if it makes a true statement, negative 14 plus 6, that really does equal negative 8. So it made that equation true. If it makes both of the equations true, though, so I'm plugging into the second equation here. Hey, negative 2 minus 6 really is negative 8 and made this equation true also, then this is my solution and I know I've got it correct. So I'm not going to show you how to check it again for your other videos because you should be aware of how to check it. You take your values, you plug them into both of your equations, make sure it makes both of them true, and that's how you know I'm correct. If it doesn't make both of them true, then it would be no solution or you've made a mistake. Let's go through and use number 4 as a way to go through and check this. Okay, we're still going to add our equations together. Remember, it's just a bunch of 1's in front of these, right? So I know that x equals 2. That's just for my note taking. I'm going to go ahead and write this there so that way this will be my solution. And now I just come back and I go, you know what? This equation right here, let me go plug the x into it. Wow, this is really easy, isn't it? Y equals 2. Now, at this point, generally someone says, well, could I have plugged in the x value for this one and gotten it also? Well, let's go see. Be nice if you could, because then you wouldn't have to worry about which equation you have to plug it into. Let's see, the x was a 2. Well, 3 times 2 is 6. Oh no, what do we do? That's going to be negative 2. Well, remember, it's like a negative y equals negative 2, or a negative 1y. So divide both sides by negative 1, and we get y equals 2. Same thing. So the question of, well, after I go through and I solve for x like I did here, after I did that, does it matter which equation I come back through and plug my x value into? No, because if I plug it into the first one, I'm going to put a check mark right there, we got y equals 2. Okay, and that's the reason y equals 2, and I had that one there also. But if you looked at plugging it into this one instead, even though it took a little bit longer because it was a little more complex of an equation, we still got y equals 2. And I assure you, if we take these two values and plug them into both equations, it does make it a true statement, because 2 plus 2 is 4. 6 minus 2 is 4 also. So, I mean, we know that it's the correct solution, and it really doesn't matter which equation you substitute them into. You still get y equals 2. Now, from here on out, here's how it's going to go. Write down the problem, solve it for the x and the y, hit play, and see if you're correct. Now it's time to substitute. And the solution is 4, 1. X is 4, y is 1. Here's the next one. Good luck. X equals 1. Now I just have to substitute it into the other equation. At this point, I want to remind you this is like a -1, so if you messed up, this is probably what threw you off. Y equals +1 for the y also, so x equals 1, y equals 1. Here we go. X equals -3, and you'll see here that y should equal -2. So x equals -3 and y equals -2. Here's number 8. X is going to equal -3. Substitute that in and solve for y. Make sure you didn't accidentally call this -12. -9 plus 3 is -6, so be careful there. After you divide both sides by 3, you should get y equals -2. Here's number 9. Starting to skip steps here, you would divide both sides by 5. That's how I know x equals 3. You should be getting a little bit more familiar with that. Now we just come back through and we plug it into the other equation. After we subtract both sides by 3, we're left with 3y equals 6. After we divide both sides by 3, we know that y equals 2. So again, if you're able to start seeing these steps and being able to skip them, be careful, but that can speed up this process. Here's number 10. Hey guys, be careful right here. -12 plus -3 is -15, so be very, very careful. X equals -3, so now we need to substitute that in. And y equals -3 also. Number 11, 2 more to go. Again, be careful. -2 plus -1 is -3, and a negative divided by a positive, as I'm showing you right here, equals a negative. So x equals -1. Plug that in and go solve for y. Now, it's normally at this point that people will get a little sloppy because they're tired of all the steps, so that's a -1 there. So divide both sides by -1 and y equals +1. So x equals -1, y equals +1. Be extremely careful. And here's the very last one. X equals 1 and y equals 2. Just a reminder, how can you check it? Well, if I want to check it, let's see. X plus y equals 3, so 1 plus 2 equals 3. Yep, that's right. 4 times x, so 4 times 1 is 4. What's 4 minus 2? 4 minus 2 is 2. So yes, it made both of them true. That's how you check it. You plug these values in and see if it makes both of them true. When we're trying to find the second variable, does it matter which variable you plug it, which value you plug it into? No, just make sure that you use one of the equations, you plug it into the correct one. If you made a mistake, like let's just say this last part right here, let's just say instead of plugging it in and used 4x minus y equals 2, instead of plugging in x for 1 here, you plugged it in there. Do you see where it's different suddenly? And you say, hey, +1 and 4x would equal 3, and then we'd have to divide by 4, and wait a second, I've got x equals 3/4, but I already had x equals 1. It's because you plugged it in the wrong slot. You can't put an x value in for a y value. So if you get into some hardships here, or it doesn't quite make sense and you're sure that you've done all of your steps correctly, it could be you just made a silly mistake like plugging an x value in for a y, or maybe you copied down the wrong equation. Maybe you just misread it. So there's all sorts of mistakes that can happen. You're just trying to minimize that, and hopefully with this practice of going through about 10 of these with me on the video, and then trying 10 more tonight before we check tomorrow in class, it'll help minimize those and also make you feel a little bit better about this process.